All right, and now let's take a look at the solution to B. And B was asking, describe a method for determining whether 4 points P, Q, and R and S lie in the same plane. So same plane. So let's go here. So it's a determine solution to B to determine whether 4 points, whether if 4 points lie in the same plane. We can compute a triple product of the position vectors P, Q, PR, and PS. Or I mean, compute the scalar triple product of the position vectors P, Q, PR, and PS. In other words, if the triple product is 0, the scalar triple product is 0, then the volume of the parallelepiped is 0, thus all the points are on the same plane. So in other words, so we have this, recall the volume of this parallelepiped is equal to the volume of this parallelogram times by the height h. And the volume of the parallelepiped determined by the vectors A, B, and C is the magnitude of their scalar triple product. So V is equal to A dot, the length of the absolute value of the A dot of B cross C. Yeah, so that's what we have there. And if all these points are on the same thing, so if you have this vector here was actually here, the height would be 0. So h is 0. So the volume is going to be 0. So instead of that, if you have it there, it becomes 0, and I'll just illustrate that right here. Yeah, so let's say we had 4 points P. So we had Q here. Say we had R here. Let's say we had S here. So if we're doing the scalar triple product, if all of these are on it, like that. So if we have this, let's say let's call this A, let's call this B, let's call this C. Yeah, and let's say that if they're all on the exact same plane, the volume here is going to be 0. So V is equal to 0. So in other words, they're all on the same plane. All these are on the same plane. They have no thickness to this this parallelepiped. No, it just becomes a parallelogram if these are all on the same plane.